Cool. All right. So welcome to the Austin Python Meetup, our ninth meetup of the 2021. Yeah, thank you everyone for coming from Austin and sometime from around the world. Today we have two great talks. We have a Collier King who's going to do a talk on FastAPI. And then we have Gil Forsyth who's going to do a talk on Nash, if I pronounce that correctly. All right. And yeah, so Gil and Collier, yeah, feel free to introduce yourself and the best you can, or the way you like. And we're going to start with Collier. So Collier, the floor is yours.
All right. Can everyone see my screen?
Yes.
Yeah, sure can.
All right.
Yep.
Great. Well, thank you for having me. I'm here to talk about FastAPI, an exciting new web framework in Python. A little bit about me. I'm a Python and automation enthusiast. I love automating stuff. We love Python. Have about 10 years working in technical roles in finance and marketing. And currently I'm a software development consultant at my company, FuseCloud. So what are we going to talk about today? Well, first we're going to talk about what is FastAPI, and then we're going to talk about web frameworks. And we're going to talk a little bit about background and history, and then we're going to look more at the FastAPI community, what traction has it had so far, what uses could it be used for, and then why FastAPI? What's so special about it? What are the batteries included with FastAPI? And then we'll do a really short, high-level coding demo. We'll look at a FastAPI app, and then we'll talk about my meetup group that I organize here in Austin. That's the FastAPI Developers Meetup group, where we only focus on FastAPI, as the name suggests. So, what is FastAPI? Well, it's a next generation web framework for developing and serving web apps and APIs. And so 4 kind of main things about it: it uses modern Python features like the Async IO framework and data validation with Pydantic. It's fast and performant, it's simple but flexible, and it has a very strong and growing community. So what's a web framework? Well, it's a package that makes creating web apps easier by abstracting away low-level details like, HTTP protocols, sockets, processes, all the kind of network kind of layer stuff that, goes into web development and the internet. This kind of abstracts it away for us. And, depending on the web framework, developers can follow a lax or rigid pattern for developing apps and APIs. And then over here, we have some pictures that just show some examples of popular front-end frameworks, some popular back-end frameworks. So the front end, we know kind of React, Vue, Angular, the kind of JavaScript world. On the back end, you have all types of different languages represented. You have Django, Flask from Python, and now FastAPI. And then you have Laravel from PHP, Ruby on Rails for Ruby, and then Node.js, of course. So FastAPI firmly sits in that backend area. So what's the history of Python web frameworks? Well, it goes back quite a while. Like it goes back to when Django was released, which was in around 2005. So Django's been on the scene for over 15 years. A few years later, in 2010, Flask came out. Flask was kind of an alternative solution that was more customizable. Django was kind of, a lot of features built in, not as many options the developer had, but it did, it definitely is well represented in the, corporate world with companies like Instagram and some others using it. I think Netflix used it. So then what changed? So December 2016, Python 3.6 came out, and that had async support. So Async IO came out, and that was kind of a renaissance for the Python web development framework world. So you had stuff come along like Tornado, Starlet, Sanic, Quart, which all were async web frameworks. And we're going to talk more about what async means, but it was a step change forward for web frameworks when Python started supporting async. And then not too long ago, about 2.5 years ago, in December 2018, this guy, Sebastian Ramirez, released FastAPI. And so since then, FastAPI has really caught on, and some of the big features about it, which we'll talk about, really drove its success. And so it's a new framework, and it's still changing and growing, and so that's what we're going to talk about. So just a really quick graphic to look at. Python, we always talk about batteries included in Python. There's so many great things in the standard library, so many great packages and libraries people have built. It really does a lot. Well, so when we look at that just in the web framework space, you have batteries included, and then do-it-yourself scale. You have that same scale. So Django has a lot of batteries included. It's very opinionated about what you can use, what you can't use. Flask is on the very other side, and it's pretty much do it all yourself. Now, there's Flask has been around for 10 years. People have developed helper packages to help do different things. FastAPI is definitely more on the do-it-yourself side, but it has a lot of cool stuff built in that takes away a lot of headache from web development. So it kind of sits in the middle, and it has a lot of good stuff built in, but it also lets you do a lot of stuff that you want. So popularity, I mean, just in the last 2.5 years, you can kind of see how much traction FastAPI has gotten. The little red time series right there shows when FastAPI came out, and these are the stars on GitHub over time. So we're just under 40,000 stars, and you can really see that growth compared to Flask and Django, which have been around for a decade. So I think this is just going to continue to grow, and it's going to continue to gain momentum. So the community, so great community behind FastAPI. The GitHub repo has 35,000 stars. There's something like 4,500 Twitter followers. There's about 100 contributors. There's about 50 top reviewers, and then 40 experts who are people that answer questions and respond to issues on GitHub. So and then there's some pretty nice sponsors they have. Solid commit history that's going on the project. So you feel pretty confident that this project is here to stay. It's going to be around for a while. Company traction. So just some quotes from people talking about FastAPI. There's some people from different companies, like this guy from Microsoft says he's planning to use it for all of his team's ML services at Microsoft, and integrating core Windows products and Office products with FastAPI. And then this person from Uber says they're using it to spawn a REST server that can be queried to obtain predictions, again, a machine learning use case. And then Netflix, they built their crisis management orchestration framework around FastAPI, which is awesome. And then just you'll search for jobs that have FastAPI in the description. I just did that search today, and it was like 326 results. So definitely not like a minuscule amount of interest out there for FastAPI. So then the ecosystem, I mean, we all, there's so much stuff, there's so many great tools in Python and beyond, and in FastAPI, there's examples of all of these things on the screen and more, integrating FastAPI with these things. So if you're going to build a web app or API, and you're looking for a security solution, or a solution to run background tasks, or you want to integrate it with your favorite database or ORM, there's so many different ways. For front-end web frameworks, you can use purely Pythonic frameworks like Jinja 2, Chameleon, and Mako, or you could hook it up to React or Vue. And then, of course, it plays nice with the cloud, Google Cloud, AWS, etc. And the machine learning, I mean, Python really takes the cake for machine learning these days. And so you can couple it with things like TensorFlow, PyTorch, Pandas, whatever you want to build kind of data-driven machine learning apps. And then testing DevOps, there's, of course, the great ecosystem around testing that you can dip into for that. If you want to test your app, maybe like, run a bunch of traffic on it and see how it's going to perform. You might use something like Locust. So, everything in this picture and a lot more, I guess, is the point of this slide. So when we actually talk about FastAPI, like, what are the things about it that have made it take off? What are the core technological components that really enable it to do well? Well, I would argue that there's kind of three big pieces. And before we talk about those, we just want to look at this little graphic someone put online. So, you have FastAPI, and then you have something called Starlet. So Starlet was an async web framework that came along kind of in that renaissance period of Python web frameworks after Async came out. And FastAPI builds on Starlet. So Starlet has the core technology, and FastAPI harnesses that to kind of go farther. And then below that, you have something called Unicorn. So this is a asynchronous server gateway interface server. And if you've used Flask, you've probably used something called Unicorn. So that's a WSGI server, a web service gateway interface server. And ASGI servers are just like that step change forward for web frameworks in Python. And we'll talk a little bit more about that in a sec, but basically Starlet and Unicorn allow async support for FastAPI. And then as far as automated documentation goes, we'll look at this a little bit more, but FastAPI offers automated documentation. So it talks about you can host documentation for your app automatically, which is great. And that's something through Swagger and OpenAPI. And then lastly, a big component that helps with development speed and just all around performance, and just makes, taps into the kind of modern Python that I was talking about is Pydantic. Pydantic is a library for validating data, which is very important when you start to think about how you're exchanging data on the internet with the client and server. And we're going to talk about all these later, but these are kind of the three big things that make FastAPI stand out because they're all built into FastAPI, the batteries included, if you will. So the first battery, async await, async technology. So, Python 3.6, async IO came out, and it was it basically is a library that, allows you to write concurrent code using the async await syntax. And so then in a web API context, it alleviates latency between the server and the client. So basically the server can work on multiple requests at the same time. And so the client doesn't have to sit there and wait for synchronous requests to be processed one after another. And so this abstracted away the need for stuff like task queues or multi-threading to do the same thing, which is inherently kind of a nasty thing when you look at Python because of some of the limitations around threads and concurrency there. So this was a huge change, a huge step forward for Python, and it's really still pretty new. And so you have a lot of stuff getting converted over to async now. And so FastAPI is kind of leading the charge there. And so just one quote from the Unicorn webpage is ASGI should enable an ecosystem of Python web frameworks that are highly competitive against Node and Go in terms of achieving high throughput and IO-bound contexts. It also provides support for HTTP2 and WebSockets, which cannot be handled by WSGI. So this really opened the door for Python to kind of play in the modern web framework space and compete against stuff like Node.js and Go. And then, over here, we have just a little graphic that shows the advantages of async versus synchronous. Synchronous, a server is going to have to do tasks one by one. These tasks are going to add up. This is going to take time. It's going to be less, it's less performant. Your app's not going to be as fast. And then async, you can just kind of spawn up a bunch of tasks, and you just have to wait as long as the longest one takes to finish, which in this case was 20 seconds. So you speed up your execution time by a factor of 2 here. And then so people publish benchmarks around different frameworks and speeds, and FastAPI is pretty close to the top. It's a fast framework, you know, and this is competitive with stuff like Node.js and Go, like I said. So this is just kind of a graphic that shows that, and there's the link at the bottom if you're interested about that. So the second battery, I talked about async.
Can you go back to the previous slide? Can you show us again the Node.js and Go? Where are they?
So these are just Python here.
Okay.
I'm sure you could probably get those in there too, but yeah, these are just Python.
Okay, how fast is it compared to Node.js and Go? Do we know?
Don't know off the top of my head, but it's up there. I think they're all in the same kind of strata of speed and performance. I don't know off the top of my head though, I'm actually not exactly sure if I understand this exact metric they're using. They're basically just pinging a server a bunch of times using the same machine and measuring the you know, responses per second. So it's you know, it's something that if you want to get deeper into, you can read about right here. But unfortunately, I'm not the expert on that.
I just wanted to clarify whether those things, like how do the Python framework compares to other languages. Go is supposed to be the language for those things. And if you're saying
so I had to do something similar a few years ago when we had to figure out which framework to use for some machine learning, serving some machine learning models. And we started not even like with machine learning models, but practically just like a super simple function behind it, and just to use some like test framework that would go and send like you can set like 100 users, and there's like test frameworks out there that you can use. And so we did something similar, like again, like about 3 years ago. And so we back then Tornado came up to the top, and Flask was somewhere at the bottom. But again, like because we are using distributed second distributed framework, that didn't matter that much. But that's kind of how you do it practically. You just like bring up a server. At least that's how we tested it. You bring up a web server, and then you use this test framework that is going to do all these requests for you, and then measure all the metrics.
Yeah. That's exactly what they did. And this is updated continuously. So if you go here, you can really see stuff across different languages. I don't have one that's shows all the languages on top. I think like there's some really fast .NET languages and ASP stuff, but I don't know exactly where Python ranks there. But within just these here, so a lot of these like Sanic, Quart, Tornado, these were really popular frameworks back in like 2017 after Async came out, because they were all kind of, you know, really performant because they were able to use Async, and now they're you know, FastAPI is actually better than those. So it's just interesting to see how the landscape shifts around a little bit. And I think that the general rule is like, if it's up here in the top 10 or so, there's not going to be like a gigantic difference, as you know, in terms of like a user noticing the speed or anything like that. But it definitely on paper, you know, they stand out. So yeah, I mean, that's something I could follow up on and try to get a little bit more information around like cross-language performance. But you know, the creators of FastAPI do kind of say that it's very competitive with those, specifically those two languages. So I'm going to take their word for it. So the next like kind of battery that makes FastAPI stand out is data validation. So this is a quote that just, I think, summarizes Pydantic very well and just describes what it does. So it's a very useful package that makes dealing with data much easier, similar to what Python's built-in data classes do. Where Pydantic shines, though, is dealing with validating and sanitizing data. So what it does in just kind of 3 bullet points is, you know, it uses type hints, type annotations, which, you know, also sort of new feature to Python. And then it forces those type hints at runtime, and then provides user-friendly errors when the data doesn't match the type hint. And then this way you can define how your data should be modeled just with Python, and then it gets validated with Pydantic. So in a web context, this makes it so that you can build response models, request models, so the data that's coming in and out of your app, your API, so that the app knows how to handle that data. Because when you think about it, I mean, everything sent over the internet is basically a string. So this is a way for your app to convert the data and return it in the right way. If you didn't have this, it would be kind of a nightmare. So this slide, I'll show you an example. So basically, there's two things. So on this side of the screen, we're going to define a user class, and we're going to have it inherit this base model class from Pydantic. So this is kind of the thing that makes Pydantic work. You just plug it into a class. And then you have your fields in your class with the type annotations, and then you can create some fake data here, like say, ID is a string, signups just another string, this friends field is a list, and then you can map that data you just had to your class. You can basically just convert it over. And then since it's a Pydantic class, when you start printing stuff out, like expecting different pieces of your class, you actually get the real thing. So you see here, like this is a list of ints for friends, and it actually prints out 3 integers, right? Like this, when you print out the sign up, it actually prints out a date time versus a string here. When this is passed in as a string, this ID, but when you print it out, it's an integer. So it's a way of like, you're gonna get messy data given to you over the internet, because that's just how the internet is. And so that your app is robust enough to handle that and use it in the right way without like totally crashing. That's where Pydantic comes in and helps a lot. And that's not the only thing it helps with. I will actually, before I show the next slide. So this is just this is an example. So this is a little sample FastAPI app over here. So we have the same kind of data model, object or class we created, and we have our FastAPI app we're instantiating there, and we're going to add a post route, so that if someone's going to want to create an item, they would do a post request to this route here, and they would pass in something that resembles this class that we defined up here. So then what Pydantic does through FastAPI is it reads the body of the request as a JSON object, and then it converts the corresponding types, just like we saw over here. And then it validates the data, and it says, if the data is not valid, it's going to return a clear error message. It's going to say exactly what field is not matching, and where the data is incorrect. And then the nice thing about it is that as a developer, you define this class here, and once you import it and you're using it in your code, like type annotations and code completion will show up automatically. So it definitely helps you, the developer, kind of know what your data is supposed to look like and model it better, which is an important thing, especially when you start dealing with databases and stuff like that.
So before you run forward, when it converts the date time or any other thing, do you have like conversion rules? Like, does it like have to be in a specific order, or like date time comes in a specific format and you specify it? Or there's a default one, or is it smart enough to figure out if I pass the date in a different format or something like that? Like ISO format, will we know how to convert it?
Yeah, that's a good question. I think it's just smart enough. I think I haven't messed a lot. I think that you would really only see a lot of iterations like that, where you could experiment a lot of different combinations with like a date time, like you said. With a string versus integer, I think it's pretty easy for it to figure that out. A dictionary, similarly, a date time might, if you did like, a weird string in here or something like that, would it still know that's a date time? That's a good question. I have not tested that, but I can try to figure that out and get back to you. That's a good question.
But if you put in like a European format, like the month and the date, or different, like here it's like month, date first, and then time. All of those things. Does it know how to? Does it have like default rules, or can you hint it, or?
I think with date times, at least, you can add time zone specifications and things like that, formatting to the date time method that you're importing. So I think you can get around, I think you can solve for edge cases like that just with the date time module itself, and just and passing that in here. I'm not 100% sure though. Like I said, it's a good question. I don't know. It's definitely worth checking out.
I'll leave you. It's like
There's definitely
so useful.
Yeah, no, that's a great question. I mean, there's definitely some magic that goes on with Pydantic. So it's kind of a new thing in Python. It's there's very useful, but still I find myself having to remind myself to use it sometimes when I'm not building like a web app or something like that. Just because I'm used to my old ways. But I really encourage people to check it out, even if they're not building, web apps per se. It does help with just data modeling in general. So we talked about how FastAPI kind of, converts data, in a meaningful way to make your app run. So that's one thing Pydantic does in FastAPI. One other thing it does, which is huge, is it actually helps generate documentation for you. So it generates these JSON schema definitions for your model. So the model would be, for example, this item class, which is passed here. So FastAPI sees that and says, okay, let me create a schema to help to document what your API is doing. And then when you go to this, every FastAPI has this. You can disable it if you want to, but if you visit the docs path at the end of your app's domain, or if you're on localhost, if you just do localhost/docs, you'll get a nice screen like this that shows all of your endpoints and custom strings you can put in for custom explanations for the user. But it also shows exactly kind of like what the model that's being passed in is, like what's the schema, what does basically this look like to the user, so the user could see, oh, I'm supposed to pass these fields in, this one's optional, I don't need to pass that, this one's optional, I don't need to pass that. So it's a way of just handing the documentation over to the developers that are going to be using your app in an automated way, which is huge because it's a pain to write documentation. So this is another one of those batteries included I was talking about, and we'll look at an example later of this in kind of real life. I guess we'll do that now. Okay, so so this is a kind of simple app, and let me know if my screen's too small. I could probably make it a little bigger. You can get like I said, one of the things about FastAPI is you can make it really simple or really complicated. It's up to you. So if you want to keep it simple, you can totally do that. If you want to keep going, make it more complicated, handle new use cases, you can do that. This example is one that's very, very simple. In the FastAPI Meetup, we actually have a full web app with Bootstrap HTML on the front end and everything like that. So if you're curious, I'll give you the link at the end of this presentation. You can go check it out on GitHub, or you can drop in one of the meetups, and that's kind of the app we use for the meetups. But this app is pretty simple. So we're just going to import a few things. We're going to import Unicorn, which is that server, that the ASCII server. We're going to import FastAPI, of course, we need that, and then we're going to import the base model from Pydantic. And then a couple other things, some type definitions from typing, and then of course just date time, because date time is so useful for a lot of things. And so this app API, it's just a toy app. It basically makes it so that you can create and list chores that you create. It's a chore app. So I'm going to put out new chores in, and I'm going to be able to look at them after I put them in. Pretty simple. So this is the model. I'm going to call it a model, even though it says class. It's the data model for our chores that we're going to be having built in the app. So it takes 3 fields. There's a name, days until alert, days until you have to do the chore. That's an integer. And then data added, that's an optional, could be, a string. And then this is our, database quote, in quotes. It's not really a database, it's just a list. But it's a list of those chores that I just defined up there. So I just defined this class right here. So it's a list of those, as you can see. In a real app, we'd of course use a database. We in the FastAPI Meetup group, we use SQLite just because it's so easy to use and local. But FastAPI can work with SQL Alchemy, any type of cloud database you want it to. There's plenty of options here, but we'll just keep it simple and use this list. And so then I'll have two functions here, and you're going to notice they're async functions. So what's async mean? Well, it just means that by wrapping a function with this async keyword, it will work with the async await syntax, which is what FastAPI offers. Now, you don't have to use async if you don't want to. That's something I should have mentioned before. FastAPI supports synchronous and asynchronous programming, so you don't have to use async. It's flexible in that way that if you want to build stuff that runs synchronously, just like your Flask app that you're familiar with, you can totally still do that. But in this case, I'm just going to use async. So this is our first function or service, and it's just going to get our to-dos back, and it's going to return a list of these, or I should say list chores. I call it to-dos, but it's just going to return a list of these chores back. And then this function
Collier,
down here. Yes.
Would you mind if I interrupted you for a question from the chat?
Oh yeah. Sorry, go ahead. Yeah.
So Eric is asking if you have observed any performance issues with using SQLite.
So I've never used it in production. I've just kind of used it for like playing around, toy apps. The thing that's nice about SQLite is that they released async support like really early on. Async came out, a few years ago. They were like really on the ball, getting it out the door. SQL Alchemy did not release async support in beta until like last October. So they were just way behind. And so if you wanted to play around with FastAPI and learn stuff, then you couldn't use SQL Alchemy for like a long time. That said, I have seen some weird stuff in SQLite where stuff just kind of persists throughout sessions. Maybe I'll have a session where I tear down a SQLite database and then spin it up again, and it'll like still have like something locked in there or something like that. So it won't do all the kind of migration stuff like I wanted it to. But again, I haven't used it in production, so I can't really talk about that. If I'm going to write something in production, I usually use like a Postgres database or something on the cloud like DynamoDB or something like that, or MongoDB, which is not SQL, but still. Is there something that they had to comment about that SQLite?
No,
they had some issues.
And Collier, thank you so much. Yeah, no, I've just seen it's a lightweight database that basically can interact with different systems. So in our experience, we have seen a little bit of performance issues with it, but I was just curious from your experience.
Yeah, I mean, I don't think I would recommend using it in like a production environment, or just even an environment where people need it to be used, all the time. I don't know, even if it's like an internal app or something like that, I would just say go straight Postgres, because it's not, I don't think it's made for production stuff. What's nice about it is it's just a file, so you can commit it, put it on GitHub, someone else can pull it down. You don't have to connect to, a Docker container running your Postgres database or anything like that. So, it's simple just to get kind of like proof of concepts up and running and things like that. But yeah, I mean, I don't think I would recommend using it much more than that. So.
Great. Thank you.
SQLite gets a bad rap. That goes back to, I first, Rails, I was a Rails developer, and a lot of the examples would use SQLite and people would throw a fit about it. I actually use it in production for things that I aren't going to get a lot of traffic. So if I'm doing, I work with a military nonprofit and they have their golf tournament, and like 30 people are going to use the app at most.
Yeah.
So something like that, it's really not an issue. If you've got simple data and it's something, you know, internal, like I wrote some friends a little API that does something that there's like 3 users and they use it once a day. So the flip side of that is, do you want to go through the trouble of installing Postgres if you're just spinning up a droplet or a little EC2 thing, or pay Amazon to use RDS when you only need to persist a little bit of data, and especially if it's read-only.
Oh yeah, yeah. I mean, for that kind of stuff, it's hard to beat that, just because, yeah, like you said, you don't have to pay anyone for it, and you could just bring it with you. Like if you're on an airplane or something like that, you don't need to, you know, connect to some remote server or anything like that to run it. You can literally copy and paste the file to someone else, and they get all the data. So it's really convenient, and they were on the ball with async. So it's, you know, it's hard to fault them. It's just, you know, there's a place for everything, I guess.
The last thing I'll say is I remember discovering that it only has 5 types and thinking, wow, it only has 5 types. And then I was like, oh, wait, it only has 5 types. So you can implement your own date time stuff in your app. It's really simple. And for most of the stuff you're doing that's not like customer work, it's fine.
Yeah.
Just my opinion.
That's why we're using it with you know, the meetup group, is because we wanted to focus more about building the apps and you know, implementing new different things. And I mean, it works with everything. It'll work with GraphQL, for example. It'll work with different things. So, you know, instead of spending a whole session talking about databases and what, you know, what database we should use, we just said, oh, we're just going to use this, because people didn't really want to focus on that. They wanted to focus on learning about the framework. So for that, it works great. So all right, well, so, you know, back to this kind of simple app we got going on. We basically have 2 functions here. One's going to get our chores back, and sorry, it's called to do. I don't know why. To do, chores, same thing. The other one's going to add chores and add a chore. And so if you look here, it's going to append a dictionary to our list here of chores. And the one thing I'll say about this is that if you notice, this is going to take a chore argument of the type chore that we, you know, defined up here in our data model. And then it's just going to pass in those elements that those fields that came from our class, you know, in as the dictionary keys. So we got the name, the days until alert. This one, I just hard coded this just so that you would have the, you know, real time you created the chore. And then this is going to return a string. So it's going to say, you know, to do added. And so then after that, we have some different routes. So this is how a route looks in FastAPI. And if you've used Flask, then this will probably look pretty similar. And it's very minimal. I mean, if you want to add a get route, post route, anything, all you have to do is wrap it with a little decorator here. So your API is the thing that you defined up here, this FastAPI object. And then you just do API.get for a get request, and then pass the path that you're going to go to. So in this case, this is the, you know, index, the route. This is just when you visit the app. If you want to give it a name, you can. The name is really more for documentation purposes. And then the function under there, you know, you can name this function whatever you want to. And then, for example, if someone visits this kind of root page here, they're going to see this message come up. You know, this just whatever JSON kind of message here.
So Collier, you're running over this because it seems that everyone knows this and this is simple. However, we in this group sometimes have people who are only starting to get to Python. So I ask you to elaborate a little bit more what happens behind the scene. What is the route at all? Because you just showed it, but people don't connect. So please, slower.
Yeah.
I ask for the sake of those who are new to Python and don't know what a route is or how it is. So please slower.
Sure.
Start with a web browser.
Of course, yeah. So a route is basically a endpoint, and an endpoint is a URL. So if I was going to go to some URL, in my app, I could just type something like this in. So this is a route right here. And of course, I don't have routes defined for a lot of these things.
And the URL there at the beginning is explain to them basically what it is, because they don't know, some people.
Yeah. So when let me go down a little bit. So when you build something like a FastAPI app, you're going to run a server on your computer. So the server that we talked about is called Uvicorn, and it's all it does is it opens a port to some domain it has access to on your computer. So in this case, it's your local host, and which is, you could type in localhost, you could type in an actual oops, I guess my localhost is different. Anyway.
No, it's not 8080.
Yeah, sorry, yeah. So, this host name, aka localhost, this is where you can define it whatever you want to, as long as your server has access to that. But this is where the app's going to run. And so then when you start going and making HTTP requests, whether through the browser, through a library like requests, which is a Python library to do requests, then it's going to hit this route, and whatever endpoint you defined up here is what the app's going to listen for. So the app, if you make a request on an endpoint, the app's going to see that, and it's going to do something. And so that's what this function does underneath the thing that's listed. So in this case, this route here, that's just kind of a /, that just means the root kind of endpoint, which doesn't really go anywhere. And so if I went here, the server which is running said, oh, he went here, let's do this thing. And so what this does is returns a little JSON object dictionary, and it says, message hello FastAPI. You could have that say whatever you want, but that's just kind of like the home page. And then for other endpoints I define, like the to-dos endpoint, if I go there, it's going to give me a list of the chores, and it's going to do that by calling this function, which I defined up here, which just returns that quote database list of chores that we defined earlier. So if I do that, these are the chores that I've defined so far. So walk the dog, water the plants, take out the trash. That's what this endpoint does. And then the difference between a get and a post is that if I get an endpoint, it's just going to return the data back. If I do a post, I'm going to actually put data to the server. So the server is going to wait for the data to come in. It's going to do something with the data. And so in this case, this last route here is a create. It's basically create a to-do, create a chore. And so to do that, I'm not going to use the browser for that. I'm going to use a little script over here, which uses this library called requests, which I'm sure a lot of you are familiar with. And so, whatever new chore we think we want to add, maybe we want to say, I don't know, rake the leaves or something. It's about to be fall. I don't know about you, but I get a ton of leaves, and it's not going to be fun. So I'm going to do this post request here, and it's just going to return back what I sent to it. And the reason it's going to do that is because first it did this add chore thing. So I passed it a chore, this dictionary, name, and days until alert. And then it added to this list, which of course you won't see here because this is hard coded in the script. And then it's going to return that chore back again, that dictionary back. And so then when I go back here and get my chores again, then you got rake the leaves now. So that is a really simple, get and post pattern for an API. And that's really like the most basic kind of, API kind of functionality that you might use. I mean, you could have an API that's just gets, you could have one that has get, post, create, update, delete, like a CRUD, structure. But in this case, I didn't want to make it too complicated. So just a get and a post, So that's a really high look at just a FastAPI app. And if you use Flask before, it's probably gonna look really similar. And I think that's a good thing, just so you don't have to relearn a lot of new stuff. It's nice and simple. So any questions before I?
Can you show us, this is great, by the way, like, thank you for explaining this in detail, but can you show us what's the documentation like for this small app?
Oh yeah, I apologize.
Hey,
Yeah,
before you do that, go back and you might want to explain response model and how Pydantic handles serialization.
Yeah, so response model is a way for the app to know, oh, okay, this person who's either submitting a request or submitting submitting a request to either get stuff or add stuff. What does the data look like what is it supposed to look like? And so if you remember, it's supposed to look like this. There's a name, which is a string. There's a days until alert, that's an integer. And then there's an optional field for a date added. So I went ahead and hard coded that, so we can kind of ignore that. But basically, every piece of data that's passed to the app or comes out of the app, in this case, if it has this chore model defined as the response model, that's what it's supposed to come back as. So then FastAPI says, oh, you passed me, a string and integer, so we're good. Or if you get the stuff back, then it's going to go ahead and convert those things back to a nice JSON object. So it's going to look at the actual data types that came out of the database, and it's just going to convert them back into the JSON object that it was supposed to be. So JSON obviously can have string, integer, floats, lists, all types of different objects in it. So in order for this to come back to you the right way, that's what this is doing here. It's saying return a list of chores. And then if we're going to add a to-do, then it's going to look for something in that format called, with a string and an integer in it. And if it's not, it's going to attempt to do those simple conversions that we talked about earlier, which was, converting something that looks like an integer, but it's really a string into an integer, and maybe a date time into a date time. So that's kind of where Pydantic comes in, is with this response model logic. You think that answered or explained well enough?
Yeah, just that Pydantic handles the serialization. You're not having to call like JSON.dumps or anything. It handles the serialization in this context for you. Good
point. Yeah, that's a good point. So and I think Flask, you would have to do that. You would have to say JSON.dumps. With other APIs, like maybe if you build an API on like a Lambda function, I think you would have to do that too. Maybe you actually could just use Pydantic in that case, but so this is where Pydantic shines and just kind of takes a little bit of extra coding out of your hands. You don't have to write extra conversions on dictionaries and JSON objects and things like that. So, and it's also nice because when you're developing the code and you're testing stuff, or you're just writing the code yourself, if you run the app and try to do stuff, it'll show you the error messages like really quickly, like almost at runtime. When you even run the app, it'll check stuff and it will send you back and say, hey, this is not the right type. And then you can know exactly what to go fix. So it just makes the development experience a lot faster when you have little helper things like that.
Can you have multiple classes? So here you have class chore. If you have multiple classes and you have a complex structure as part of your request JSON, does Pydantic support that in terms of multiple fragments?
Yeah, you can have, so this chore class that inherits the attributes from the Pydantic base model, you can keep passing that along as far as you want. So you can have this chore class be, go inherit to another class if you want. That's maybe like a regimen or something like that, which is like a collection of chores or something like that. So So as soon as you kind of instantiate this class based on this base model from Pydantic, it goes all the way down. So it's nice like that. It's just the classic Python polymorphism kind of built in. So so yeah, you can keep going with this, and you probably will at some point, because you're going to want to use these not just for validating the data that comes back and forth from the app, but also when you start working with databases. I know we kind of skipped over databases, but there's a way for Pydantic and SQL Alchemy to just work right together. And so SQL Alchemy will look at the Pydantic data class, the types, and it will craft the tables that you create in the database based on those. So it's really flexible and useful.
Show us the
docs.
documentation. Yeah.
So every FastAPI app, unless you explicitly disable it, you can just go to docs, and it brings up a nice screen here. And if you want to, you can add a lot of text here, add extra, explanations around stuff. If you want to customize it, for maybe it's like your internal company app and you want to use like, your company logo or other things on it, you can do all of that. But so what this is just basically just a list of the endpoints that we have in the app. So we have the / route, which is home. And this thing doesn't take any parameters, and it returns just a string. And if we go back here, it just kind of matches this, because this doesn't really do anything. It just returns a string here. And then when we start looking at these, like if I'm going to get all these to-dos, then this is going to take, as far as like what's getting passed back and forth, it has an example value here, which is just kind of like the fields that are in that chore object here. So it just passes that Pydantic class along to the schema. So it actually just creates this nice example for you. And then it actually creates this list too. So if you want to look at, a little bit more detailed description about what each field is, it adds that as well. So then me as the developer, I can come along and say, oh, this is exactly what I'm going to get back when I do a GET request on this route here. And then it similarly, if I'm going to post a to-do, if I'm going to like add a chore, then this is similar. It's example value and then a schema. So this is what I, as a developer who's using this API, would come along and say, okay, I need to pass, the chore object looks like this. So I need to pass a, dictionary JSON object, just like I'm doing over here, with these fields in it. So that's just nice out of the box kind of documentation. And you can add as much extra stuff as you want in terms of descriptions on each route, the whole thing. You can do some pretty fancy stuff too. You can add like more examples and things like that. So it's always nice as a developer when you read someone else's API docs and it's like really good documentation, because there's plenty of times where it's not, and it's just you have to kind of just trial and error until you figure it out. So this is super useful. And the important thing is, if you don't want to show all this information, you can disable this too. And you could disable it for like certain routes if you wanted to. So that's docs, and that's kind of just a really high level sample app. So any questions?
Yeah, I do have one question. So like, it's kind of similar to the question before that. So if you have like more complex types of like models, like for example, here you have a chore, but then the fields are more complex. So you have something like that's nested, some kind of nested type of structure. Like how do you define it? Do you define another? Let's say you have I don't know, I'm trying to come up with something. You have a field that has a bunch of other fields inside. Like, do you define another class and then you refer it in here, or how do you?
Yeah, you could do something like this maybe. So you might do something like chore list or something.
Okay.
And then this would be a list of chores. something
Okay.
like that.
I see. Okay.
So you can just kind of keep building on what you built
I see.
before. Just keep building it on. So.
Okay. All right, so you can use the class that the model that you defined before, and that's how you can nest like more complex data structures.
Yes. Yeah.
Cool.
So I don't want to take up a whole lot more time, but we're kind of at the end anyway. So where, as someone who's learning FastAPI, what do I recommend as someone who's been learning it for the last, I don't know, I guess I started learning it back in like April-ish, May. So if you want to keep learning, there's some really good documentation out there. There's just a few resources. So I put together this Google Sheet here, which is in the Austin FastAPI Google Drive. And it has just a spreadsheet of like, here's an article and here's the things that they talk about in the article. And it covers, there's tons of content in there, and I can probably just open it up really quick. So, there's, if you're interested in Postgres, there's, articles on that. If you're interested in, maybe using Elasticsearch or PyTest or Docker, there's, just different articles I found, and I'm constantly adding to this list. So, go ahead and check it out if you want. And then if you want to just look at kind of what the experts say, this is documentation from the creators of FastAPI, and they continuously add new articles about how to do stuff. And so if you have a specific use case you want to do, like maybe you want to use some machine learning models or something like that, then this is a good resource for you. And then as far as courses go, I mean, I do recommend, if you really want to get into it, like there's nothing that really beats a course to help you learn. And so these are a few different ones. So the Talk Python guy, Michael Kennedy, he makes really good stuff. So these are two of his classes. And then the test-driven folks, test-driven.io, they have 3 classes now for FastAPI. I think they're like $30 each. So they're like, not too expensive, and they're really good. So those are just some ideas. And then I'll, give a little plug for the meetup. So, it's a pretty new meetup. We've only had 4 meetings so far, or this will be our 4th one this month. But basically the goal is to build and showcase APIs and web apps, and we spend about an hour each meetup. And we spend, 30 to 45 minutes going through a coding walkthrough, which includes kind of a presentation like the one today with, more like architectural content, like slides and diagrams and things like that. And then we have kind of general discussion at the end, like 15, 30 minutes or so. And so these are some resource links. Here's the meetup group link, and then the GitHub repo, and then the Google Drive, which has these slides and some other older slides too. And then this is what we've covered so far. We just talked about kind of the introduction, and then, what you could use to build an app as far as designing the file structure in June. And then we talked about authentication in August. And then this month, we're going to talk about GraphQL. So early days, but, a lot to do ahead. So please come check us out.
You're going to repeat this multiple times, like each time, like you're going to do like 6 months courses or like 7 courses and repeat it each year, or are you open to new topics? I'm asking.
That's a good question. Yeah, so we're definitely trying to kind of constantly talk about new things. So, for example, GraphQL, we had some people that are interested in using it for either their jobs or just out of curiosity. And so that's kind of, once we passed kind of some of the basics, we started talking about more advanced topics like GraphQL. But like it's an open discussion. We talk about the code all the time. We talk about we rehash the topics a lot. So it's not like, even if you don't have experience, you can certainly come join. And you're going to get a lot of content, so you'll be able to learn about the basics anyway. And then there's nice slides and documentation for each of these subjects in the past too. So if you want to learn about just the intro, or you know, the basic fundamentals behind building an app, like the, you know, what the folders look like, what the files look like, then you could look at the slide from the second meetup. Or if you want to just learn about authentication, you could look at the slides from that meetup. So there's lots of content that we just keep adding.
Okay, so just to emphasize the point, so people will hear it strong here. The people from the Python meetup here, do usually come to this meetup. Do join the FastAPI meetup. It's not on the same page as us. It's a different meetup page, but do go there if you're interested, especially the beginners. If you want to learn a web framework, this is where you should start learning, and don't be afraid of asking questions there. The people there may be experts, but they will help you.
Absolutely. No, I mean, we're all learning, and I appreciate that. And I'll just say that, you know, it's a really exciting time to learn web development and API stuff, because once you build your awesome machine learning models, you're going to have to host them to the world. So now Python's just as strong in, you know, web development as it is in machine learning and other stuff. So, you know, if you learn Python, you have so many tools at your disposal now. And so this is a really nice shiny new toy for people to play with as they start to go out and kind of show what they built to the world. So yeah, thank you for having me. I appreciate it. Yeah.
Thank you. All right. Thanks so
Can we do
much.
a round of applause?
Oh yeah, definitely.
Thank you for that. That was great.
Yeah, that was awesome. Thanks so much.